The obvious thing is we don't have a choice. You can't build 100 times or 50 times or 20 times the current energy capacity that we currently have terrestrially in the time frame that there is the demand for it. It is extremely difficult to build stuff in space, but it's the only place we have. There's literally nothing else. Once Starship's live, they're going to have just a complete monopoly on launch. It's going to get much more concentrated in Starlink's, in SpaceX's hands over the next 5 years. Here's the thing. In a hard startup, there's only one thing that's hard, and that's making the technology work. In everything else is easier. So hiring amazing people, a lot easier. Fundraising is easier. Getting people to write about you in the press, much easier. Getting people excited about it in general is much easier. But you need to deliver the technology, and that's much harder.
Hello everyone, and welcome to the 15th episode of Audio Token, the podcast where we try to create audio tokens for our future AGI overlords for them to train on. Today I have Philip Johnston with me today, CEO of Starcloud, which is a company that tries to put AI training chips in space, so making data centers in orbit. So welcome to the pod.
Thanks very much for having me. That is a great name for a podcast. I only just figured out what it means.
I appreciate it. Yeah, I have to remind the audience every time why it's called that, because otherwise most people wouldn't understand. Yeah.
The AGI is going to cut that part out because it's too repetitive.
Yeah.
No, I'm joking.
Yeah. So welcome to the pod. And the obvious first question is obviously why space? Why would you put them in space? Maybe you can give a bit of a background also, what it is, the TLDR of the company, and then why do you put them in space?
Sure. Does your audience know that we're building data centers in space, or should I explain? Yeah, I'll explain what we're doing. So we're building very large data centers in space in order to be able to take advantage of the abundant energy in space and the ability to scale almost indefinitely without the kind of permitting constraints that you have terrestrially. Those are the two biggest reasons. There are some other benefits around networking and the fact we don't have to boil huge amounts of fresh water to keep them cool. But there's also other challenges around cooling and other things. So,
Okay. And so the two main reasons why you put them in space is location, like space on the ground, and then also energy storage, and I guess that's from solar panels.
Yes.
I
wouldn't say it's space on the ground. There's a lot of places on the ground where you can put data centers. There just isn't many places on the ground where you can build very large energy projects without a decade-long permitting cycle. So it's not so much a data center that is constrained on the ground. It's more the energy project to supply energy to those data centers, which is constrained on the ground.
Right. Okay. So, famously, I think Elon Musk, when he did the Colossus data center, he just attached his data center to the closest pipeline for natural gas or something. This is not feasible in the average case, or?
It's not, sadly. Well, sadly and not sadly. The Colossus was only 200 megawatts, for example, and Elon has bought every gas generator in North America, as far as I understand, just to power that one data center. But no, it's essentially not the number of places where you can either draw that amount of power from the grid or build an energy project of that scale is there's basically not many places in the US where you can do that. And the other thing is data centers are getting much larger than 200 megawatts. Meta's building a 1 gigawatt data center, and there's plans afoot for a 10 gigawatt data center. And Elon just tweeted 2 days ago saying he is coming up with concept designs for a terawatt data center, so 1,000 gigawatt data center.
Yeah,
which, in my view, the only place you can put that is in space.
But a terawatt, that's 3,000 times or 5,000 times the amount of the 5,000 times more than the biggest data center at the moment, right? So, correct. Or the biggest AI supercomputer. So maybe not super feasible.
Well, we're on this absolutely insane exponential curve right now. I think it's a bit like if you had, in 1850, if you said in 100 years, what will be the largest power plants? and somebody said it will be 10,000 times bigger than the current power plant that we have, you'd probably think that was crazy too. But by 1950, they were certainly larger than 10,000 times the current that they had in 1850. And I certainly think there will be demand for that. Whether we have the ability to build that terrestrially remains to be seen. In fact, it's almost certain we don't, but we do have the ability to build them in space. And
Right.
that's really why we're doing what we're doing.
Right. And what are the other alternatives? Like you said, Meta is building a huge one. What are you doing instead of buying every single generator on planet Earth?
Mostly people are looking to nuclear now. In the short term, nuclear fission, and in the longer term, nuclear fusion. You can also build very large solar projects. I think Elon's also looking at large solar projects terrestrially. Yeah, I mean the problem in the long term with nuclear is there's two problems. Number one is it's not actually that cheap. Like the cheapest power source you can get with a new nuclear fission project is around 8 cents per kilowatt hour. The lowest forecast I've ever seen for nuclear fusion is 20 cents per kilowatt hour. And that's by Helion Energy. They're the most incentivized to give a low forecast. We're targeting quite considerably less than 1 cent per kilowatt hour, including the cost of launch with very large solar projects in space. Problem with very large solar projects terrestrially is nobody wants them in their backyard. So getting permitting to cover like 10 square kilometers of land with solar panels is like very challenging, and particularly in North America. Maybe not all over the world, but in North America for sure.
Right. And you anyway want the solar panels to be close to your data centers, right? Can you
Yeah, but you can.
create?
I mean, you can. Yeah. Oh, that is the other problem as well. If where the power is generated is usually deserts and hot places, and that means then your PUE, which is like a measure of efficiency of the data center, how much power is going into cooling, is way worse. So if you, for example, build a solar project in Arizona where there's lots of sun, but then you have to build your data center in Arizona too because you don't want to lose all of that energy in transmission, then now half of your electricity for that data center is going into cooling. And the big problem is most big data centers are cooling by boiling fresh water, and Arizona doesn't have a huge amount of fresh water. So if you're not doing that, you then have to spend even more energy on cooling. So so one big problem is with nuclear is it's not even that cost effective. The second problem is there comes a point, and we see it around 50 to 100 times the current electricity generation capacity, where your the amount of heat that you're pumping out into the atmosphere from these data centers is enough to warm the Earth very significantly, and much more than anything we're expecting with warming from fossil fuels. So we're not talking like 2 degrees of warming, we're talking like 10 or 15 degrees of warming. And this is purely because you're pumping hot steam out from data centers into the atmosphere. And that starts to become a problem around 50 to 100 times the current capacity. Might sound like a long way off. I personally don't think it's as far off. I think it's within our lifetimes that we're going to have 50 to 100 times the current power generation going into data centers.
For
And
data centers, or is this like electricity need in general?
That's for data centers, just for data
Okay.
centers. 50 to 100 times the current data center capacity. You start
Yeah,
to have
that
problems
seems
with.
not that far away,
Yeah, yeah.
to be
And it's
honest.
within our lifetimes.
Yeah.
And so at some point, you need to figure out a way to get this, to dissipate this heat into the vacuum of space, into deep space. And that is the core technology that we're building, which is very large, low cost and low mass deployable radiators. Um, yeah, I mean, that is the big challenge with building data centers in space is you don't have air, so you don't have convection or conduction. So you have to build these huge surface area radiators to dissipate all of that heat into a vacuum.
Okay. So yeah, we're going to get into how it works, but maybe start from level 0 on the ground. Like how are you going to get them up in the first place? I guess SpaceX is
Yeah.
solving that for you, but yeah, any interesting details in that?
Yes. So we're launching our. Maybe I can paint you the roadmap because I think that's probably the easiest way to
Yeah,
explain what we're
that's
doing.
great.
So yeah, we've got a first launch in August this year, so coming up in 3 months.
Congrats.
That's Thank you very much. We're launching on Falcon 9. The mission is called Bandwagon 4. It's basically a ride-share mission where you have a bunch of different payloads. So that's like a 60-kilogram small satellite, around 1 kilowatt. We're going to be launching around 100 times more powerful GPU compute than has ever been operated in space before, including state-of-the-art terrestrial data center grade NVIDIA GPUs. If you know anything about GPUs, it's the one that you're thinking of probably. Um, but I'm not. I shouldn't say it because my co-founders get upset.
Can I say
So
it?
no, because
No.
So yeah, we're launching that. It's going to be a good demonstration, but we'll also be running. I mean, we'll be the first to train a model in space, first to run high-powered inference in space, first to do fine-tuning in space, first to do. Um, we'll run a version of Gemini. We'll run. I mean, we're going to do some really pretty hefty demonstrations on that one. We'll also run a customer workload with a US military satellite, and I can't say who that is yet. And that's essentially running inference on raw imagery that they'll send us. So rather than them having to wait for a ground station to downlink data, they will send all of that raw imagery to us. We'll process it, find an insight, and the insight might be there is a vessel in this patch of water moving in this direction. Rather than having to downlink 500 gigabytes of raw imagery of open water, you can just downlink that insight, and that insight might be 1 kilobyte. So that'll be the first demonstration. In fact, this for the first 5 years, I'd imagine almost all of our revenue will come from this edge compute work use case, 3 to 5 years maybe, where we're providing an edge service for other satellites and other spacecraft. So that's this year. Next year, we've got our second satellite launching. It's going to have about 100 times more powerful, or the satellite itself will be 100 times more powerful again, in terms of its power generation, solar panels, etc. That one will have a rack of what will then be the latest NVIDIA chips. And that one will provide the first commercial service. So it will be an upgraded extension of what we currently do. And then the plan is by mid-2028 to launch a 1 megawatt satellite, and that will most likely take the form factor of the Starship PEZ dispenser. And then the ambition is by the early 2030s to be launching essentially one full Starship payload bay. So that's about 100 tons of compute, solar panels, radiators. We're estimating around 30 to 40 megawatts of data of compute with the solar panels and radiators. That's the one where the unit economics of it start to become clear. Maybe I can, if it's helpful, I can just touch on how that works. So
yes,
if you run
and which year was this? This was
that's early 2030s for one full
2030s.
Starship payload bay.
Okay, yeah.
Yeah, for the listeners who don't know,
and for sense, that's a tenth of current Colossus data center, like the biggest AI data center at the moment.
yeah, I mean the average Meta data center is around 100 megawatts. So
Right.
compared to a Colossus, about 10th, but it's on the same order of magnitude as as a reasonably
Right.
sized data center
Yeah.
terrestrially.
Yeah, I mean, and you put it in space, so it's a bit more badass than than that.
Well, we're desperately trying not to do things because they're badass. We're trying to do things because they make commercial sense. Yeah, but it is more badass. I'll give you that. So yeah, we'll be launching one full Starship payload bay. So if you run that's about 40 megawatt data center. If you run that terrestrially for 4 years, which is how long we're expecting the chips to last, and let's say your energy cost is 10 cents per kilowatt hour, it's like close to what a nuclear power station would be. Then your energy cost alone over those 4 years is about $140 million. Versus with what we're doing, you can launch it for, depending on who you believe, maybe $20 or $30 million. The marginal launch cost for Starship, for SpaceX, is expected to be like $3 to $5 million per launch. So depending on what they charge customers, it could be $20 million. The solar panels are another $5 million, and then all of the other costs are roughly netting out. So the cost of the chips is similar, the cost of the coolant loops on the radiators is similar to the cooling towers on a terrestrial data center. So instead of $140 million, you've got $25 million for launch and solar. And the real advantage is you can then scale that almost indefinitely. So if you want to build a 200 megawatt data center, you can launch 5 of these pods and have them up and running in a month, versus, a 200 megawatt data center is going to take you a decade to get permitting for an energy project of that size in the US. And then you don't have to stop there. You can scale to multiple gigawatts. And that's where on the website we have this concept diagram of a 5 gigawatt, 4 kilometer by 4 kilometer Death Star of a data center.
All right. Okay. And so the final form is that like Starcloud has their own like satellites going around multiple ones, and customers can be part of that, or is it like more like you give the service to people and then they have their own data center?
You can think of us a bit like a CoreWeave or a Lambda. So we will essentially rent H100 time to the hyperscalers, to folks like Microsoft and AWS. So yeah, right now at CoreWeave, what they do is they rent compute time to these guys.
Okay, yeah, makes sense. And how does maintenance work? Like I know GPUs they burn out quite often, and then you have to like swap them out.
Yeah.
Would you have like a humanoid robot to do that, or what's the plan?
Have you been reading my posts?
I have, as a podcast host should before a podcast for preparation.
I appreciate that.
No, they're good. I
Um,
enjoyed it.
yeah, okay, nice. That's the one I get most often called like a crazy science sci-fi like person about. So to answer the question, the first satellites will be very similar to Starlink and any other type of satellite in that we will not be able to touch them once they've been launched. And so the way you handle that is you have to have redundancy on the critical systems and then over provision on things which will degrade over time, for example, the solar panels and radiators. So that costs slightly more, but then we have some savings on the energy cost. The later versions and in general, actually, that's quite similar to a concept that Google has, which is these modular data centers. It's basically a shipping container they would take to somebody's parking lot. You put it there, it has 3 ports in and out, cooling, connectivity, and power. And you basically don't open it for 4 years. And then at the end of the 4 years, you return it back to Google. So it's a similar concept to that for the first few. Over time, the space industry in particular, is moving towards robotic maintenance. And it's a trend that we expect to continue. And as you rightly point out, a humanoid robot actually doesn't require any modification to operate in space, in that you can essentially just put it in a spacesuit. So a spacesuit takes care of thermal pressure, like the air pressure, for example, radiation, and all the other things. So Elon will be launching humanoid robots to Mars in 2026. People will then realize, oh shit, this is actually going to be an extremely cheap and efficient way of building large structures in space. So it wouldn't surprise me. I don't like to bang this drum too hard because it's the one where people get most offended about, but it really wouldn't surprise me if we see humanoids building large structures in space.
Yeah, no, I don't think it's like that crazy. Like the AI progress have been outpacing everyone's imagination, and I expect this to come to robots as well. And I mean, another
Yeah.
trend is that launch cost is going down a lot. So yeah, I don't know. It seems quite feasible.
Yeah, people have no idea what's about to happen with the launch cost. It's not just that the launch cost is coming down. The launch cost might come down by 100x, but even if it's only 10x, it's still good enough for what we're doing. Um, but what's really interesting is the launch capacity is going to go up by an enormous amount because they're building enormous capacity to produce starships. And the thing about a starship that's different from a Falcon 9 is once it's built, that capacity stays there. So a Falcon 9, you have to rebuild the upstage every single time. With Starship, it just accumulates on itself. If you build a new one every day, by the end of the year, you've got 365. Whereas if you build a new Falcon 9 every day, by the end of the year, you've got one. um, so that's why the launch capacity is going to go up by such a huge amount. And they're planning to build a Starship Gigafactory, which has the capacity to produce 3 starships a day, which is mind-blowing capacity, given that it's 100 tons, like 5 times more payload than any other launch vehicle.
Right. Has the progress so far with their launch attempts been on schedule, or
They're about to do they just did the 8th launch.
yeah?
The last
I don't
two
mean
launches.
literally on schedule. Like
Uh,
the trend of their like yeah, of their progress,
their
is that
progress.
like is the progress
I mean, it's going blisteringly fast compared to any other launch program. It's behind what they said it was going to be, but it's always behind what they say it's going to be. But I mean, compared to, for example, New Glenn by Blue Origin, which they've literally taken 10 years to do one launch. Um, SpaceX has done 8 launches and they've been going much less time. So yeah, it wouldn't surprise me if we see within 12 to 18 months they're launching once a week. That is just it's just staggering capacity. It's just mind blowing the amount of mass you can get to orbit with one Starship launch a week.
Right. So apart from you said people are not going to are not realizing what's going to happen. Like, so apart from having data centers in space, what else is how will the world be different with more launch capacity?
Yeah, I mean, there's a few things that will be possible when you have much lower launch cost and much higher launch capacity. I think asteroid mining is certainly something that is within the realm of possibility at that point. Um, so is resource in situ resource utilization on the moon, they call it. So the moon has large amounts of helium-3, which is very valuable for quantum computing and for fusion. So I think that will be a thing. Potentially manufacturing in space, particularly low, zero or microgravity manufacturing will be a thing. I'm a big fan of space hotels. I hope that becomes a thing. Certainly more constellations like Starlink will be economically viable. And then another one that's just cool and interesting is astronomy will explode because it will be very cheap to put a telescope up. Right now, the amount of time you can get on the James Webb, if you want it, is so limited that it really restricts our ability to do things like find exoplanets on around other stars and or find ones that look like Earth, because you really need to be watching the same star for a very long period of time, and the James Webb just doesn't have the capacity for that. But soon, with low cost launch, you'll be able to build your own telescope to do that.
Cool, cool. Yeah, so I guess we expect to find maybe life on other planets as Elon Musk reduces the launch costs. So
I
you
don't know about that, but maybe.
okay.
At least we
Why
expect to
not?
be able to rule it. We expect to be able to rule it out.
True, true.
At the moment, we
So
can't
so
even rule it out because we don't know.
why do you think that?
Do you know this thing called the Fermi paradox? Are you familiar with this?
Yeah.
Yeah, yeah. I can't get my head over. To me, it is truly a paradox. I can't get my head over this feeling that the galaxy should be teeming with life. We should see it everywhere. It shouldn't be hidden. Um, it wouldn't take very long to colonize a galaxy at all. A few million years. So, and it's been going for 10 billion years at least. So I don't know why we don't see other life. And the only conclusion I can come to is uh, intelligent life is very short-lived. Could be one
Right.
sad fact.
Okay. So you think that intelligent life might happen in the future on other planets, and it might have happened in the past, but in like at the
Almost certainly has
short
happened in the
okay,
past. Yeah.
but in the short period that we live, the probability of two civilizations having intelligent life at the same time is low. Is that your opinion?
Yeah, and I think the reason for that, or having detectable intelligent life, is low. And I think the reason for that is once you hit um, a point where you could get to superintelligence, like once you'd be able to start sending high, high, you know, signals out into the galaxy, it's not long until you hit superintelligence. It's only like maybe 5 or 10,000 years, and 5 or 10,000 years like blink of an eye. So yeah, I do think it's very unlikely we'll see other civilizations around at the same time as us. Yeah, and I don't think we're unique. I mean, yeah, I would like. I'm trying to be optimistic about it, but uh, yeah, it's very tough.
So back to the optimism of your company. So you talked earlier about the like the core technology that you build to enable this, the radiator thing with the cooling. Yeah,
Yeah.
can you maybe explain how that works?
Yes. So just to illustrate the point, when you are, yeah, the one of the biggest power usages of a terrestrial data center, maybe 20% of the power in an efficient data center goes into cooling. And usually the heat sink of that cooling is a cooling tower, which is essentially boiling fresh water. So we don't have that in space because we don't have large amounts of fresh water to boil and we don't have an atmosphere. So we need to find a new way of dissipating that heat. And the way you do that is by what's called black body radiation, which is essentially where you just have a large black panel or surface, and that will emit infrared if you keep it at a certain temperature. So if you keep it, we're planning to keep our radiators around 50 or 60 degrees, and that will on the cold side even, and that will emit around, I think it's 800 watts per square meter, and the solar panels generate around 200 watts per square meter. So we need about a quarter the size of the radiator. So a quarter the size of the solar panel needs to go into a radiator. Um, Now, if you have a kilometer by a kilometer solar panel, that means you would need to have 500 by 500 meter radiator, and that obviously means pumping enormous amounts of fluid. Dissipating heat through that distance is actually extremely challenging, and so that's essentially where all of our efforts going. The biggest radiators right now are on the International Space Station. As I understand, they're dissipating around 70 or 80 kilowatts. We're Our radiators potentially, when we're up to a megawatt, it's like 10 times that size. Um, so yeah, it is possible. It's just expensive right now. So we know it's possible because it's done on the ISS. Our challenge is, can we do this cheaply and with low mass, and mass produce them?
Right.
And
And
I won't go into the exact secret sauce of how we're doing that because that is truly our secret sauce.
I see. I see. Okay. And so you launch it up with SpaceX, then you build a data center, you have the solar panels for the energy, and they run, and then you dissipate the heat, and then how do you transfer the data back? I guess that's the life cycle of the entire operation.
Yeah, I mean the data transfer back is pretty much solved now because of the mega constellations. So constellations like Starlink and Kuiper and Kepler. So we'll in the end state we'll be using optical. So we'll plug into one of these mega constellations. You have very high data rates using lasers. So I think it's public that Starlink lasers are a 400 gigabit a second data rate. You can have multiple, you can have 10 lasers coming off this thing. You can't point in the same direction because they interfere, but yeah, I think the physical limit is around a terawatt per laser, when you're using basically every frequency within the laser, or as many as you can. Um, so yeah, that's the way that we get the data back.
Okay. So which part of this is like the hardest? The launch, the energy, the maintenance, or the transfer of data?
The bit that is unsolved right now is the radiator, and that's the bit that we're
Right.
solving. Yeah,
Okay.
launch is solved, transferring data is solved. Um, Maintenance also needs to be solved, but I think we're moving in the right direction. But what we're working on is the radiator.
Right. There's been other alternative places to put data centers. I know like Microsoft tried to put them undersea. Yeah, maybe we could like go through the list of possible other places you could have gone to and why why you didn't go there. So first, like why? Because
Sure.
Microsoft's project under the sea didn't work, and they closed it down last year. Like why was
Yeah.
that?
Well, you don't get free energy under the sea for one thing. So, as I understand, one of the reasons they were doing it was for lower cooling cost. But in an efficient data center, your cooling cost is only 10% of the total energy cost, 10 or 20%. Um, so it doesn't really solve the problem to go under the sea. One of the main reasons they were doing it, as I understand, actually was to be close to the Trans-Pacific and transatlantic cables for things like you wanted to co-locate an exchange close to the London Stock Exchange, for example. You might put it out to sea slightly, um, in one of these data centers. So just to give you, shave a fraction of a millisecond off the time. But I don't think they were doing it because it's much more efficient to do it, for example. So maybe they just didn't find a customer for that use case.
Hmm. Okay.
Where else are you going to say? You're going to say Antarctica or Alaska?
I don't know, like maybe because you said that really finding terrestrial space wasn't that big of a problem. Maybe my other places doesn't really make sense because I thought that was bigger of a problem. I've heard all of these like documentaries of people complaining that they built a data center next to my house and this is decreasing my quality of life so much and complaints like that. But that is that
Oh,
because they have to build it there because that's the only place they can get energy permit, right? But like
I presume
building it
that's it.
on
Yeah,
but building it like out in the Siberian forest or something, you wouldn't get a permit there, or like you couldn't bring the energy there. So therefore, there's a lot of
yeah.
land where you actually couldn't put them.
Yes. It's very
But
dependent on the energy.
but surely, like I mean, yes, if you get them to space, then that's amazing. But like, surely the technical challenge of putting them in space is bigger than the technical plus regulatory challenge of, I don't know, adding extra cables to Alaska or something.
But cables from where to where? Well, where are you building these
Okay.
these energy projects? You still need to
Right.
build an energy project somewhere. Yeah,
Right. Yeah. Yeah. Fair enough.
yeah.
Fair enough. Um.
I mean, so you're right to a degree. If I thought that the total global energy demand was going to stop growing at 2x what we currently have, I'd be like, you're right. It is an absolute pain in the ass to try and build data centers in space. Let's not even bother trying. Let's just figure it out on land. But what's going to happen is we're going to need basically to double it in the next 3 years, and then double data center capacity for AI in the next 3 years. And what do you think is going to need to happen in the next 3 years after that? It's not going to stop growing. It's probably going to double again in the next 3 years after that. So 4x what we currently have, and then double again after that. So 8x what we have. And we don't have a choice. I think that's the thing. When I sometimes speak to people and I can't get into their like noggin. Uh, to me, the obvious thing is we don't have a choice. You can't build 100 times or 50 times or 20 times the current energy capacity that we currently have terrestrially um, in the time frame that there is the demand for it. So it is extremely difficult to build stuff in space, but it's the only place we have. Like, there's literally nothing else. So we have to
Yeah.
figure it out. And that's what we're
Yeah.
doing. We're figuring it out.
Yeah, I think it makes a lot of sense. Like, it's obvious if you believe that AI is continuing on this super exponential that we're on, that we're going to need more energy. I think I've always thought in the past that this means that we need to build more nuclear powers plants and all of this thermonuclear, all of these different energy projects. But like, yeah, if the
There just
main
isn't
thing
enough.
that you're
Yeah.
solving is that you can get it almost like for free in space, then that seems definitely worthwhile, and might be the only solution, as you say. So if because I've always thought like, okay, so why are there not more startups building like energy grid infrastructure or yeah, more fusion startups or whatever, or like downstream of nuclear reactors, projects like that. But then okay, this might be an alternative solution. So then my question is like, if this is the solution instead, then we should have more startups that build stuff in your realm. So like, what problems do you have? Where do you think there should be more startups? Like, are there like
Hmm.
sub problems of your problem that other startups could solve?
Uh, I have to be a bit careful here because I don't want. So if I was starting a new startup, I would probably just start like a radiator company startup.
But that's what you're
Like,
doing.
but that's literally what we're doing. Because these radiators are um, useful for every high energy use case in space. I think building large data centers in space is the first thing you would do, and it's the most sensible thing to do if you have low cost access to space. But there will be many other use cases in space, and all of them, be that space hotels, be that manufacturing, be that refining or asteroid mining or anything else, will require dissipating large amounts of heat in a vacuum. So this technology we're building is extremely valuable in general. So yeah, I don't want to encourage too many competitors, but building radiators in space is definitely a good idea.
Surely you think you will
I
win
mean,
anyway.
we will win. I mean, we've got the best team in the world to do it. So the guy behind me was at SpaceX for 4 years, MIT grad, and we hired the guy from NASA's Jet Propulsion Laboratory who designed the radiators for the Europa Clipper mission. It's NASA's most expensive ever probe to Jupiter. Um, Also designed the radiators for a recent very successful lunar lander, which I am not allowed to name. So I mean, we have by far the best team in the world to do this. If people want to have a look, check out our team, starcloud.com/team. You want to see the most cracked engineering team in the world.
That's the spirit. Why did you change name? You were called Lumen Orbit before?
Yeah, we got a cease and desist from Lumen Technologies, sadly.
Okay.
Although I
thought
actually
it
much
was
prefer the new name.
okay.
Oh,
Yeah, that's
did you
good.
think it was because of the TV show? Because I only started was it Lumen
I didn't,
Industries or whatever.
but please go on.
There's a TV show on HBO or something called Severance where there's this evil company called Lumen, and it only, do you know the one I mean? Ben Stiller
Uh,
that directed it.
I don't watch that many TV shows, unfortunately, so no. But okay, yeah. But okay, I thought it was something like you wanted to maybe own the name of like when now you like put when you talk about the cloud storage, you like, oh, I put it in the cloud. And then I thought this could be something like you want to run it in the cloud, and then you want your name to be, I don't know, associated with the new paradigm of how you run stuff. But okay, then we know. So
Yeah.
with AI, what is like AI is going to triple and double and all of this, like be super big industry. How big does it need to get for your thing to make sense, or is that even the right question? Like, would it make sense even if
The
AI stopped today?
It would make sense even if AI stopped today. The right question is, um, what is the launch cost for our thing to make sense? Um, the reason AI is a driver of what we're doing is you need to build new data centers and new power projects continuously. We wouldn't be doing it if it was like we're going to wait for an old like power plant to shut down, because once you spend the capex, the marginal cost of energy is pretty low. So it's not like we're going to compete with old gas power stations. We're competing with the new ones because they're the ones that have more capex that needs to go into them. Um, but yeah, eventually it would make sense. You would just wait 20 years for them to shut down the gas power plants because they've run out. And instead of building a new gas power plant, you would build a new data center in space if the launch cost was below, a few $100s a kilo. Marginal launch cost, as I say, with Starship is projected to be $10 to $20 a kilo. So it really just depends on what SpaceX decides to pass through to the customers. But somebody will have access to that. It could be SpaceX that has access to that price. And so it is inevitable once the launch cost hits a certain point.
Okay, okay. So even if we have the current AI capabilities and like the demand of electricity for AI or whatever, then it still makes sense to do this, even if it
Yeah,
doesn't increase. And then
we're
if it
just competing
increases,
on energy cost.
yeah, and then if it increases, that would be even more. So like in general, like what so how would AI impact the space industry? Like just before we started this podcast, you were like trying to figure out your headphones, new headphones, how do they work? Go to ChatGPT. Is that like I feel like I always also have this experience, like every new thing I do now, it's just like ChatGPT all the time, and it makes my life so much
Yeah,
easier. And I
same.
imagine being in a very like complex, maybe not as well documented domain as in the space industry, that you would have a lot of advantages compared to like space startups 10 years ago with ChatGPT, or is
Oh,
that not
100%.
the case? Yeah.
100%. I mean, you can set ChatGPT o3 or one of the research models, maybe Gemini or one of the others. Let's say, for example, you want to know um, what is the um, capacity factor, like the amount of heat that a substance can, or yeah, how much heat can a material absorb that we could use in a radiator. So you have different materials like water or ammonia or ethanol or whatever. Just get it to find out. the physical properties of like the top 100 most likely contenders, rank them um, by viscosity and boiling point and freezing point and blah blah blah. Find the most suitable one, like that type of thing. It just takes ages before you have ChatGPT. Like you're just searching reams and reams of like documents and stuff. So, and then obviously on CAD, like computer aided design, CAD modeling, you can. There's a lot of good text to CAD models out there now. So you just say, I want a widget that looks a bit like this, and put a picture, and it will populate that into CAD basically. Um, so yeah, compared to a company without using AI, it would be a nightmare.
Right. Do you trust the output or the famous hallucinations that people used to talk
This is where
about?
there's varying opinions among my teammates and I. Broadly, I trust everything it says blindly, but I know that's not how. I mean, it screwed something up yesterday, so it wasn't a big problem. But um, I think it's much better to err on the side of trusting everything it does blindly than it is to err on the side of always being overly cautious about everything, because very soon it will be able to do everything. So um, it, one big mistake I see some people making with um, with AI is they'll try one prompt, it won't work, and then they won't try it again for another year, or they won't try again for another 6 months because they think it's not, it's rubbish. Whereas what you should do is just alter your prompt and put a bit of effort into it, because very soon it will work. And it won't be 6 months; it'll be 1 month before that prompt does work. Um, so any company who's not, yeah, I mean, I sound like a boomer CEO who's like terrified that their company's going to go out of business. But if you're not ahead of this, you're going to get absolutely destroyed by companies that are ahead of it. Um,
Right. And the other things like in general, the space industry, how will it be transformed by this new wave of AI?
there was an interesting when there was the SpaceX Starship catch. They caught
Yeah.
the booster. I was actually
Chopsticks.
there. Chopsticks. Yeah, I was there for the first catch, the fifth launch. It was freaking amazing.
Nice.
Yeah,
In
most
in in
insane
real
thing I've
life,
seen.
it was in Texas,
Yeah, in
right?
real life.
Or
Yeah, in South Texas, Boca Chica. Now Starbase, Texas. Um, yeah, one thing Elon tweeted after was he said, "Not bad for a bunch of monkeys," and then he wrote something like, "There was no ML AI that went into this at all. It was all basically just people like coding. Okay, move this thing here when this thing comes here," which is really interesting. But that will not be a thing for very much longer. All engineering like that will be AI ML run very soon. Um, yeah, I don't know. Yeah, that's as much insight as I have.
right. So like classic control theory stuff will be replaced by data learned algorithms
It's,
instead.
especially things that are so dynamic like that. Yeah.
Yeah. Yeah. Yeah. Okay, that makes sense. Uh,
What do you think?
yeah. Yeah. I think that we've been on this trend for a while. Like I guess the new transformer-based models maybe are not the thing that's revolutionizing that kind of uh, that kind of data or like that those kind of problems.
No,
But
but things like full self-driving are the things that are revolutionizing that.
yes, but I think I'm a bit rusty on the full self-driving stack. But like 2 years ago, the self-driving stack wasn't really using a lot of like the big data transformers.
It's end neural nets now.
Yeah,
It
I know
Yeah,
some companies are doing it end to end, like Com AI
Tesla is.
and to some
Tesla is.
extent Tesla. Or are they? Are they?
Yeah.
Okay, okay. Uh,
And to have it, if you haven't been in the Tesla full self-driving, it's amazing. It's just like it can drive much better than human can now.
hmm, okay, yeah, that's impressive. Yeah, I thought maybe also the like in general the space industry, if you have to like navigate a bunch of I don't know regulatory forms, stuff like this, then that's another like avenue for
Oh yeah,
revolution.
for sure. Yeah,
If they
yeah.
can just answer all of them, I don't know. Like, is that as a startup? Like, do you spend a lot of time doing paperworks like that because you're in the space industry, or Is that
We do, yeah. I mean, there's FCC filings, and then there's things like actually the main one recently is grant writing applications for these in the US. They have the SBIR, Small Business Innovation Research Grants. Um, like you can basically once you've written one, you can then get it to populate everything. You use that as a context window for every other grant, and it'll basically do that.
right? How's the process to get like the thing you're launching in August? Like, how was the process of getting onto that mission?
I'll tell you because it surprised me. So we started the company January 1st. On January 2nd, we were like, all right, let's just book the earliest launch we can and get something on that mission because we knew it was going to be like stuff 2 years out was filling up. So we literally went on SpaceX.com. I paid with my credit card, $5,000 deposit, and we booked a launch.
That's
That was
it.
how easy it was. Yeah. And we had a launch booked, and I sent an update to our investors as well. I was like, "Yeah, we've booked a launch for 15 months away," and they were like, "Wow."
So okay,
But
so
it was as simple as going on SpaceX.com and putting your credit card down.
and what do you get then?
And
Then
then
you get
after you've done that, then you have to
yeah,
go through this massive long process. But actually booking the launch and getting the slot fixed is incredibly simple now with SpaceX.
right. And the slot is you get
Because
some kind of like 1 cubic meter or something of
yeah,
space or
you get they call it a quarter plate, which is basically that much that much space. Yeah.
about a cubic meter or
Something like
for the
that, yeah.
people for the people that listen and
Yeah,
didn't see your hand gesturing.
yeah, yeah.
Yeah. Okay.
Is this going to
Uh,
be is the video going to be is it coming out on video as well, or is it just
it's
audio?
video and audio, but there's some people on Spotify that won't see it if I don't narrate over it. So, but okay, okay, and the thing after that's horrible to go through with paperwork
Um,
and stuff.
it
Or
wasn't too bad to be honest.
okay,
It's much worse if you're a European company, for example, because then you need to go through ITAR to ship all the stuff in to the US. But for us, yeah, it was not too bad. I shouldn't speak too loudly about this because no, not loud. I shouldn't speak too confidently about this because my co-founder did most of that, and he might
okay,
be like, "No, it was terrible."
I see, I see.
uh,
So
yeah,
you previously did
FCC is a challenge.
I see. You previously did another startup, more traditional software startup, right? How does it compare being in a like space startup? I think the Boom CEO, he said that it's much easier to do supersonic jets because it's so cool. So then the hiring is solved basically because everyone just follows you. So counterintuitively, he thinks it's like easier to do very hard things. Is that something you
Yes,
subscribe to?
yes, I very much subscribe to that, and I think Sam Altman has this very amazing blog post called like "Hard Startups" or "Hard Things" or something like that, which people should read. And yeah, it is a counterintuitive secret that um, I mean, I feel yeah. Again, I shouldn't speak too confidently about this because we haven't yet succeeded, and if we end up not succeeding, then it's yeah, it's a huge failure. So yeah, I wouldn't want uh, to talk too loudly about that. But here's the thing: in a hard startup, there's only one thing that's hard, and that's making technology work. In everything else is easier. So hiring amazing people a lot easier. Fundraising is easier. Getting people to write about you in the press much easier. Um, like getting people excited about it in general is much easier. But you need to like deliver technology, and that's like
Yeah.
much harder.
Hmm. Hmm. So you build a company like Datacenters in Space. It's AI focused, but like you also said that even if AI is not really a big thing, this makes sense for like other applications as well, just general data center usage. But let's
Yes.
assume that let's assume that you really hope that AI becomes a thing for your company's sake,
I'm not even sure I do hope it. I just think it's so inevitable. Like
right?
it would
What are
be
your
foolish
timelines?
not to. Well, I believe there'll be 50 gigawatts of new energy capacity required over the next 5 years in the US. 50 gigawatts. That's like 50 nuclear power stations are the biggest nuclear power stations we've got. It's
Right.
just it's a lot.
How much does the US use today?
It's on the order of about 70 gigawatts, I think.
So it's almost like doubling. What?
Yeah.
Okay.
Could be the next 3 years. This is not even necessarily the next 5 years. Yeah.
And
This
this
is in
is
line
for AI.
for data centers construction in general, but almost all of that is for new AI data centers. This is in line with the McKinsey forecast as well. McKinsey is usually very conservative on the stuff, so yeah.
So one question I had around this, like if AI becomes this powerful, then it will become like part of national security or whatever. And then
It already is.
and there's been this worries that like should we really trust the Saudis with all their like Saudi money, because then they would want the data centers to be in Saudi, and then we need to put like the AGI in Saudi Arabia, and that might be national security. How does this work in space? Because space doesn't really have national boundaries, right? Would the countries want to put their like most advanced technologies in like an orbit that orbits other countries, basically?
Um, I mean, they already do for one thing. I mean, the Starlink network is about $10 billion worth of assets in space orbiting other countries. An attack by one country on another country's satellites would be considered an act of war. I mean, that's in the Outer Space Treaty. So, I yeah, I think space will become an increasingly contested domain, and you see that in the things that the Space Force are doing, and the types of companies they're awarding grants to, for example, like orbital transfer vehicles that have fairly offensive capabilities. So yeah,
What's the TLDR of this outer space treaty? You're not allowed to attack other countries' satellites.
basically, yeah,
That's it.
it's
Okay.
basically like first come first serve on orbits and on um and like it's basically says space doesn't belong to any one nation, neither does the moon, and yeah.
Okay. Okay. But like, yeah, SpaceX, all of Starlink is worth a couple $1 billion. That's a lot of money, but I mean, it's also spread out around. Like, if some rogue country wanna like attack it, they could probably only get maybe a tenth at best. So that's $1 billion. Like, if we have AI like AGI running on a data center in space, and that's like worth trillions because it's like AGI,
Well,
then
AGI will be very distributed. I don't think there's going to be one place where AGI is running. Also, which I should say, yeah, the concept video we have is more on the mid to late 2030s timeframe. That's the 5 gigawatt centralized data center. What's almost certainly going to happen before then is we'll just be launching these Starship-sized 200-ton, 50 to 80 gigawatt sized modular data centers, and those will be run independently, and we'll have hundreds of those orbiting before we start trying to hook them together. Because the only reason you need to hook them together is to run very large training clusters, and that will be a long time before we have enough computing space to consider running a very large training
right.
cluster. So it's mainly for
Is
inference that we'll be using it for initially.
okay. So it's mainly for inference. Okay, interesting. And that's because training needs more bigger clusters, basically, because you have to store
Yeah.
more gradients and stuff. Okay, makes sense.
Because you need the data center to be internally networked at a
Yeah,
very high capacity, much higher than you could have on a distributed a bunch of
right.
data centers.
Yeah, okay, makes sense. How? Okay,
I love the fact we can see your duvet in the left corner there. By the way. It's like blue with like flowers on it.
yes, it's beautiful. It's a beautiful Airbnb bed.
Okay, fair enough. I thought this was your bedroom, like a home or something.
I don't currently actually have a bedroom. I'm moving from place to place Airbnbs. I just got my O1
Yeah.
visa, so trying to
Oh,
figure out
nice one.
where
Congrats. Whereabouts are you?
in San Francisco. So
Oh,
yeah,
okay. You should
that's it's
you should come up to rainy Redmond.
Is that where you have your office?
Yeah, we're in Redmond, Washington, because Starlink is here and Kuiper and AWS now.
Ah, okay. Why do you need to be there? Like, is it why do you need to be close to that?
For talent, like we're all of
Okay.
Starlink is here. People don't realize we started down in LA in El Segundo in January last year, and basically everybody we were trying to hire was up here because down there people know about launch and propulsion and aerodynamics and things like that because of SpaceX, but they
Yeah.
don't know anything about satellite building, or not many people do. Whereas up here, I think it's
Uh,
something crazy, like 80% of all satellites launched in the last 3 years were designed and built in Redmond. And that, when Kuiper goes online, that number is going to be 99 or 95%. Um, so all of the talent is up here on the satellite side. And then on the data center side, you have the headquarters of AWS and Azure, both in
hmm,
Redmond. So,
hmm. Okay, makes sense. One technical, I mean, challenge you also will have is like radiation. One thing in general, when I've been thinking about space startup ideas, is always like, oh, but you have to make the computer radiation proof, and then it's like, oh, then it becomes 1,000 times more expensive or something. Is this a problem for your setup?
um, it's a big problem in a very mass constrained launch environment. Um, it's not as much of a problem after that. So until now, what people have done is they fly these what you're talking about, these like radiation hardened chips, like rad hard Jetson and other types of chips. Um, they are they're very expensive and very non-performant, about 100 times less performant than what we're going to be flying on our first satellite. Um, so yeah, well, you can either solve it by flying very low, so you fly kind of under the Van Allen radiation belt, what's called VLEO, very low Earth orbit, 380 kilometers and below. That's where we're flying for the first two missions, first mission at least. Then, if you want to fly higher, then you basically need more shielding. And for the later missions, we will do that. What's nice about this is as the satellite grows in size, the proportion of mass that goes into the shielding trends towards zero. And the reason for that is the compute scales with the volume of the satellite and the shielding scales with the surface area. So basically, the larger the satellite, the better. And you can also use the radiator and things like that for shielding. But yeah, so that's one side of things, which is you don't need as much. Like you're not as bothered about mass in a low launch cost environment. Not the second thing is the types of compute that we're going to be running, which is training and inference, are actually much less vulnerable to radiation effects than other types. And the reason for that is you have a high degree of stochastic and randomness in those types of algorithms anyway. And so
Hmm.
one bit flip doesn't actually really make too much difference to the output. Um, yeah,
You
why are you
just
smiling?
decrease you decrease your dropout coefficient by 10%, and then that's
Something
sorted
like that.
by.
Yeah, basically. Yeah, another way of putting it is there's algorithmic ways of radiation hardening your chips.
Okay, 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 makes sense. Um, so you said previously that you are a fan of space hotels. So famously, Jeff Bezos want to do space hotels. Elon Musk want to go to Mars. Do you prefer space hotels in that debate, and why?
No, I prefer Mars.
You prefer Mars. Okay, how
Yeah,
why?
yeah. I'm a um what's the word? Like I like the drama of um space exploration. So space hotels is very frivolous. If you have to choose between becoming a multiplanetary species or having a few low Earth orbit hotels, 100% want to be a multiplanetary species.
Right. When do you think we will have humans on Mars?
I have a bet with somebody that Jared Isaacman will be the first person to walk on Mars sometime before 2040. What do you think about that? Do you know who Jared Isaacman is?
Yes, but I have no clue if that is a feasible bet or not. I've heard promises of it being sooner, but yeah, famously those promises are often missed. But I don't have a.
The bet is very specifically Jared Isaacman, and I think I win the bet if he crashes on impact, but I don't win the bet if the rocket blows up on launch.
Okay. So because
Anyway,
like he's the current NASA guy, right? Yeah,
yes, yeah,
and will look 2040. Like why do you put him? I feel like he would be out of office before then.
he will be out of office, and that will be what will enable him to be the guy. He's the one that's been paying for all these missions. Like he was on Inspiration 4 and all the others.
Yep.
So
Yeah.
I think he's lining himself up. Like he's paid enough. He'll be the first to be in line. Yeah, I think
Right.
he's lining himself up.
Right. If they called you to do it, would you do it?
If I get to be the first person, yes. Second person, no.
Okay, makes sense. How and okay,
I'm not
second
sure.
person.
My girlfriend will kill me if she hears that. But um, yeah, if I get to be the first person, then yes. If have to be the second person, then no, definitely not.
I guess third person
I
no, fourth person no, hundredth person, the thousandth person. What?
that
Where do
is
you
a
get back to the yes?
that is a very astute observation. There is definitely a fulcrum at some point.
Yeah.
Well, is there? I don't know. If I'm like 70 or 80, I'm not sure I want to spend 6 months in a tin can, regardless. Yeah, at that point, I mean, I'm very happy to go to the moon. Like it's a week there and back. Mars is quite an endeavor. Um, yeah, especially if I have kids. If I don't have kids, maybe I'll YOLO it. But
I see. I see. So SpaceX is in these conversations all we talk about with launch costs and stuff. Do you think this dominance will continue much longer?
yes, in fact, it'll get more dominant probably. Because of Starship. Nobody's trying to do anything like Starship right now. So once Starship's live, they're going to have just a complete monopoly on launch, and that will give them a complete monopoly on the Starlink like capability. So yes, it's going to get much more uh, concentrated in Starlink's in SpaceX's hands over the next 5 years. In a 10-year time frame, maybe not, but 5 years for sure.
Right. So the other like Rocket Lab and all of these other smaller startups, Relativity,
They're all great,
they
but they're not even trying to compete with SpaceX on Starship.
right. Okay. Yeah.
Nobody's
Fair
trying to
enough.
build a reusable upstage,
Yeah.
and that's
Why
like
is
the
that?
key unlock because bloody hard. I think that's the main reason.
Eric Schmidt recently like bought Relativity, and do you have like opinions or what do you think will happen with that?
Well, you saw his tweet saying he bought it because he wants to build data centers in space, or no?
I did, yeah.
Yeah, yeah,
I'm teeing you up here.
yeah. I appreciate that. I'm knocking it out the park. Um, yeah, I'm very happy that he's trying to build data centers in space. I think that's cool. If I was him, I guess it's like a sunk cost fallacy thing. I guess he poured so much money into Relativity before. I think he probably put like $500 million into Relativity already. And there was a question of, do we let Relativity go bankrupt and we literally just shut everything down and we sell the equipment for parts? Or does somebody like Eric Schmidt put in another 50 million or something, basically own the whole company and then just use the parts? That's probably the way they priced it, is whatever they would have got selling the parts. Um, I mean, it's a very tough thing to do, to take a workforce that is like demoralized. All of their equity's gone to zero. They all thought they were millionaires, and remotivate that type of workforce and get them back on track. And maybe his thought is like, we'll take the parts and we'll basically start from scratch. Like we'll rehire a team. And I think that's probably what he's doing. Because the alternative is starting from scratch, and that might cost him 100 million. So he's probably like, well, I've already put in 500 million. Like, might as well get some money for what I've put in already. So yeah, but I mean, to be honest, I wouldn't start a launch company now because you really are just competing with SpaceX, and SpaceX are just so damn good at executing and so fast and so far ahead that yeah, I can't see how anybody can compete with them for a very long time.
Right. And like Blue Origin, they recently had their answer to uh, to Starship with New Glenn, but like you don't see that's a feasible path to a competitor.
It would be if they were trying, but they've not announced anything about trying to build a reusable upstage. So,
Right. Okay.
like
Okay.
their
Fair.
launch cost can't ever go below $500 a kilo because they're gonna have to rebuild the upstage. Actually, sorry, I should clarify. There is one which is Stoke Space. They're trying, but Stoke Space's vehicle is so much smaller that it's that their costs will be higher for sure. I'm not sure how much higher, and maybe they can make something work, but yeah.
Hmm. Hmm. Okay. Um, what do you think is going to be the thing that you are the proudest of in if you look back in 10 years?
I hope I have a family, and I hope my kids.
That's a wonderful way of ending it, and I hope you get to live that, and you put the data centers in space. Thank you so much for talking with me today.
Thank you so much for having me. Great to speak to you, Lucas.